All right, so this is section 2 for IM 1 called Order of Operations. Again, I'm really hoping this is just kind of review for everybody. So let's go ahead and go over the pieces here at the top. So this is the notes area at the top here. We're going to go over evaluate and then order of operations, which has a bigger notes area down below. So first, evaluate. What does evaluate mean? Because they ask us evaluate these expressions all the time. In fact, that's the first thing we come across here. It says evaluate expressions. Well, what does that mean? It just means to solve or to simplify. That's all it means. Okay? It's just, that should be an M, simplify. So we just want to figure out what the answer is. Simplify it as most you can is what that means when it says evaluate the expression or evaluate these equations or however it's phrasing it. So evaluate, before we move to that one, order of operations. So this one, again, should definitely be review. We should have been hearing this for quite a few years at this point. It is very important for simplifying an equation. It's actually more simplifying an expression. You use order of operations to simplify, not necessarily to solve the entire problem. So order of operations, which we'll go over down here, is Pemdas. So this is our easy way to remember it. It's just meant to help you remember the order. So parentheses, then exponents, multiply and divide from left to right, add and subtract from left to right. So you kind of do these together. So you don't just do all multiplication and then all division. You do multiplication, division in order from left to right, just like you're reading. Same thing with addition. You do addition and subtraction in order from left to right. And that just ensures you're not moving negative signs or, kind of messing with the operation in any way if you do it from left to right instead of trying to kind of piece it together. All right, so let's go ahead and evaluate these expressions down here real quick. Remember, an expression just means it doesn't have an equal sign. This doesn't say 2 to the 4th power equals 10. It doesn't say equals that. It doesn't say equals anything. So this is just an expression is what we call it. And also, we went over this in section 1 really quickly, but when we have an exponent, it doesn't mean 2 times 4. What it's telling me is how many times to multiply the base by itself. So if it's 2 and I have a little 4, an exponent of 4, it means I have 4 2's. So 2 times itself 4 times, not 2 times 4. I know that sounds very similar, but that is very different the way I'm saying that. 2 times 4 is simply 8. That's not the answer here. We want 2 times itself 4 times. So 2 times 2 is 4. 4 times 2, because I use that answer, I use these 2. Now I have 4, I'm going to multiply by the next 2, and I have 8. 8 times 2 gets me 16, and I like doing this little step over because it lets me know I've used those ones, and I just keep stepping over until I've used them all. So the answer is 16 here. So we want to make sure we're paying attention to the difference when we're doing exponents. And it's really just a way to write repeated multiplication. Instead of writing 2 times 2 times 2 times 2, I can just write 2 to the 4th power. It means the same thing, it's just a shorter way to write that repeated multiplication. All right, so same thing with this, 4 to the 5th power. We have 4 5 times. So I'm going to write my 5 4s with my multiplication in between them. So 4 times itself 5 times. So I have 4 times 4, and I get 16. And then I have 16 times 4, which we get 64, times 4 again. Sorry, that was kind of an ugly. So this one goes up to here, and that was the 64, and then 64 goes up to this one. So we have 256. See how quickly this grows? And now I have to multiply by 4 one last time, and we get 1,024. So we start off with something pretty small, just a 4, but by multiplying it by itself over and over and over again, it grows very quickly. And this is the idea of exponential growth. It grows very, very quickly. All right, so now we have 7 to the third power. So 7 3 times. So we have 7 times 7, and we get 49. And then 49 times 7, we get 343. So again, that grew pretty quickly. I only multiplied it 3 times, and I'm up in the 300s already. So we just want to make sure we're paying attention to those exponents because they do grow very, very quickly. All right, let's scooch down and look at this graphic for order of operations. Come on, scooch all the way up. Okay. So this is just kind of a cute little graphic for order of operations to help you remember everything. So the first thing, always work left to right. And I've made that point already, but it's definitely important. You always want to work from left to right, just like you're reading. You don't want to try to skip around on that one because it can mess up the operation that you're doing, especially when there's negatives thrown in there. Or actually division will also get a little messed up if you're not working in the correct order. So this just shows you kind of very quickly what these mean. So P for parentheses, E for exponent, M for multiply, D for divide, A for addition, and S for subtract. And if you notice, there is an or there. So it's multiply or divide, add or subtract in that order. So these two steps are done together. And so are these two steps. They're not separate steps on multiply or divide or add or subtract. So I'm going to go ahead and write parentheses, exponent. Sorry, I'm squeezing it in here. Exponent. Multiply, divide, add, or subtract. Oops, I don't know why I put an extra S in there. Subtract. And then they give you another area here because remember there's that funny little poem that everybody tends to remember at this point in school, just to help you remember it. So please excuse me is what my dear Aunt Sally is saying. So this is just kind of a silly little cartoon to go with. Please excuse my dear Aunt, whoops, stuff popping up here, Aunt Sally. So that's just the little poem that helps us remember this. Please excuse my dear Aunt Sally. So parentheses, exponents, multiply, divide, add, subtract. Just helps you remember that first letter of our order of operations here. All right, so let's go ahead and practice some of these. So we have 3 practice problems here. And again, remember we're going from left to right, and we're just going to go down the order of operations. So first we're going to look for parentheses here. I don't see any parentheses, so we're going to move to E for exponents. I also don't see any exponents in this problem, so we're just going to keep right on moving. Now we're looking for multiplication or division from left to right. So when I go here, I have 3 plus 42 times 2. There's some multiplication right there. So I have 3 plus, we're going to do this multiplication. 42 times 2, I get 84. So I'm just rewriting. 42 times 2 is 84 minus 5. I brought down 3 plus, I brought down minus 5. I haven't done anything with those yet. There is no other multiplication or division, so I'm going to move to addition or subtraction, and I'm going to go from left to right. So 3 plus 84, I'll do this one first. I get 87. So I just added those two together, minus 5. Now I can do these last 2 pieces, and I get 82. So there's my answer. All right, let's go ahead and look at 2B here. So I don't see any parentheses because we have to go back to the top here. We're starting with parentheses. So I don't see any parentheses, but I do see an exponent right there. So that's our next step is E for exponent. So I'm going to simplify this. Everything else just comes down. 20 minus 7 plus, now instead of 8, squared, I'm going to write 64 because that is what 8 squared is. Remember, it's not 8 times 2, just like we practiced up here. It's 8 times itself 2 times. So 8 times 8 is 64. Minus 7 times 11. All right, so now we're going to move to multiply or divide. So we're going to go across here until we find multiplication or division. So the first one I see is 7 times 11. So we have 20 minus 7 plus 64 minus 7 times 11 is 77. All right, so now we're going to do addition or subtraction from left to right. So 20 minus 7, I get 13 plus 64 minus 77. 13 plus 64 is, let's see, 77, and minus 77. So 77 minus 77 is 0. So my answer on that one ends up being 0. All right, last guy here. We do have a lot of different parentheses here. And remember, parentheses don't just look like this over here. So they're not just these rounded parentheses that we see over here in the little graphic here. Sometimes we have these brackets like this. Or sometimes we might even have these little kind of fancy brackets that we have. It just depends on how many layers of parentheses we have. A lot of the time, once we've used the rounded, kind of the basic parentheses, then they'll move to brackets, which are the squared off ones. And then they may move to another one for the next layer. So really it's just telling us there's more than one layer of parentheses. And you want to work from the inside out when you're doing that. So we want to go all the way to the inside here. We want to do this first. So we have 15 minus 10 plus 3 minus 2 is 1. And then that'll be squared, so we'll deal with that in a little bit here. Plus 6. All right. So now we have to look inside of these parentheses here. So we're going to have to deal with 10 plus 1 squared. Well, before I can just simplify the parenthesis, what's inside of there, I'm going to have to also do order of operations within the parenthesis. So 15 minus 10, I can't just do 10 plus 1 squared. I have to deal with the 1 squared first. So 1 squared, 1 times 1, because that's what that means, 1 times itself 2 times, is just 1. Doesn't matter how many times the number of the exponent I can put on there. I can do 1 to the 1,000th exponent. Doesn't matter. It's still 1, because I'm still just multiplying 1 by itself. And then plus 6 is still on the outside here. Now I can deal with this 10 plus 1. So I end up with 15 minus 10 plus 1 is 11. And I can drop the parenthesis now. I don't need it anymore. And if you notice, I dropped that parenthesis up here when I did 3 minus 2. I didn't need it anymore. I just dropped them. So once you've simplified and you're down to one number, you really don't need the parenthesis anymore. You can drop it away. So now I have 15 minus 11 plus 6. I only have addition or subtraction left. So I'm going to go through and start doing these pieces. So 15 minus 11, we get 4 plus 6. So 4 plus 6 gives me 10. All right. So that was our practice with order of operation. Now you will go on to Alex and you will complete a homework assignment for this lesson. And you can refer back to this video if you need any help. All right. See you in lesson 3.